Hey y'all, welcome back. Today we're checking out the forgotten tech marvel that changed absolutely nothing.
This is a British hovertrain. Yep, a British hovertrain exists and has done since 1970.
Okay, before I started watching this, y'all, this is Luke O'Sullivan. Be sure to go like and subscribe. I'm already subscribed. I will give it a like. I just read the very first sentence of the description, and it says, in the 70s, the UK tried to build a train that hovered. It looked like something from science fiction, and it actually worked. And then I stopped reading. That's amazing. A hover train? A hover train. This is like from my 9-year-old boy dream. Like, wouldn't that be cool if it floated? So, sorry to stop the video so quick. I just wanted to get that out there. That's amazing.
This is a British hovertrain. Yep, a British hovertrain exists and has done since 1970, though it might not do for much longer. It wasn't some billionaire's passion project, it was an infrastructure project backed by the government who pumped £130 million into it in today's money.
What?
So, what happened?
What happened?
If we were one of the first, why won't the UK's new high-speed 2 be as fast as Japan's new maglev trains? Why have so few of us heard of it?
Yeah.
Society's been obsessed with hovering transport since the mid-20th century. We can all picture that futuristic vision of cars flying through the sky and trains hovering along beams.
Hoverboards from Back to the Future Part 2. We were told they were real, and they weren't. Robert Zemeckis.
In the 60s and 70s, people really tried to make this a reality with nuclear power, Concorde, and a few other wild visions of the future. This project was part of that, engineering the new world. And historically, the UK was pretty good with trains. We had the first steam trains, we were an early adopter of electric trains, and with high-speed rail on the horizon, the UK government didn't want to fall behind. So, with the French developing the TGV, which is a conventional high-speed train, and the Japanese launching the bullet train, the British response was this, the tracked hovercraft.
Developed by... I'm sorry, the what hovercraft? The tracked hovercraft. Okay, yeah, it's on a track. Great, yeah. Like a train. Perfect.
This, the tracked hovercraft. Developed by leading pioneers in engineering, it didn't run on wheels. Instead, it hovered on a cushion of air, eliminating friction. And while it was developed by a private company, most of the funding came from the government. The company set up a...
That seems like a lot of air. I thought he was going to say magnets. But air. So they're lifting it up with air. That seems like a lot of power. I don't know where this is going, but that seems unsustainable.
By a private company, most of the funding came from the government. The company set up a facility in Erith, Cambridgeshire, and picked a very straight and flat spot next to the old Bedford River to build the test track.
I'm sorry. Erith, Bedfordshire. Show me on a map. Bedfordshire? Where's that? It's just north of London. Okay, moving on.
They actually picked this because the land conditions were so bad that if they could make it work there, it'd work anywhere. A test vehicle was built at Vickers in Swindon, and a 1-mile test track was completed in June 1970. After some troubleshooting, Research Test Vehicle 31, or RTV-31, did its first public test run on the 10th of December 1971, reaching a top speed of 15 miles per hour.
Okay.
Now, this isn't particularly speedy, but it was a remarkable feat of engineering. It worked by using high-powered fans to blow air, making it hover. To reach the crazy speeds they had in mind, they planned to combine this air levitation with magnetic levitation, using a linear induction motor, or LIM. This would have provided both lift and also propulsion too. To get an idea of how it would have worked, imagine a train floating over a metal plate with magnets on either side pushing and pulling it along. There were no moving parts, just clever use of electricity and magnetism. It must have seemed incredibly futuristic. And it was. The goal was 250 miles per hour, faster than any train in Britain, even today, even faster than HS2's expected top speed. No shade. Now, when I was here checking it out for the first time, I kid you not, I bumped into a man who actually worked on the hovertrain. His name is Ted Tyndall, and he was known as Mechanical Systems Engineer. He told me a bit about his experience working on the project.
Every test run, I was there.
So, hang on. It worked on air and magnets. I guess neither one of them alone was powerful enough to keep it lifted and going forward. It sounds like they used the air to keep it off the track, lifted, and the magnets to propel it forward. That's really smart. That's technology that's been around for, well, I don't know, at the time, almost 100 years, right?
Every test run, I was there recording all the facts like wind speeds and so on, what problems we encountered, what speed we attained, and so on. It was reasonably quiet. The main noise, of course, was the fans, the lift fans. And then, of course, once the power was turned off, it dropped onto the skids, which had the main stopping power. Additionally, at the end of the track, we had an aircraft arrestor hook, and instead of being inclined downwards, it stuck upwards. That stopped it, all right.
Oh, those hooks from an aircraft carrier, it looks like, right? Yeah, but it was upside down, so it would, like, hold it up off the track?
Downwards, it stuck upwards. That stopped it, all right.
He told me about how the train drew an incredible amount of power from the conductor rails on the track. In the archive footage, you can actually see sparks flying as the train moves.
We run at far higher voltages than anybody had ever attempted on conductor rails before.
Yeah, okay.
Whereas I think 1200 between Manchester and Bury was the maximum power through conductor rails. We were taking up.
Yeah, you can see the sparks. That doesn't seem efficient, does it?
Whereas I think 1200 between Manchester and Bury was the maximum power through conductor rails. We were taking up to 6,500 volts.
6,500 volts? That's a lot, I think, right? I feel like I should know voltage, but I don't. What can you do with 6,000 volts? Not getting a clear answer. We'll go to the robots directly. Please give me a real-world idea of the amount of power that is 6,000 volts. Okay, yeah. The volts is not the amount of power, like you need amperage to. Okay. Everyday comparison. A US household outlet is 120 volts. A UK household outlet is 230 volts. A stun gun or taser is 50,000 volts, but very low current. So 6,000 volts is far above anything you'd encounter in a home. Industrial equipment, a subway, uses 3,000 to 6,000 volts. Power transmission, 4,000 to 7,200 volts. Okay. It's not a crazy amount of power. It's actually about the same amount of voltage as a subway would use. Maybe that's why it's sitting in a junkyard, is because it didn't really save power. Because it seems like the whole idea of raising it off the track would be to reduce friction, to reduce power. But it's not really happening, right?
Through conductor rails, we were taking up to 6,500 volts.
As time went by, work continued. They fitted more powerful motors, more track was built, and they discussed extending the test track to up to 18 miles. The speed increased too, eventually reaching more than 100 miles per hour in February 1973.
Oh.
But despite the project making progress, there were still a few big challenges. RTV-31 was a massive 22-ton vehicle, about as heavy as 2 double-decker buses. That meant that making it hover was power hungry, with massive amounts of power required to help the fans blast it off the track.
Yeah.
And the big one, it couldn't actually carry passengers. At least not yet. This was a test vehicle, and the windows have been painted on by Railworld, its current home.
Oh.
There was no facility for carrying passengers. And that, of course, is where the system fell down. Because if people couldn't take a ride on it, they weren't going to put their money to it, especially when the Minister of Transport visited. And his first question was, can you ride on it? He was told no. And of course, that rather reflected on the proceedings.
Yeah, what's the point? I mean, I guess you could transport goods with it, but like, huh. Very interesting.
Just 1 week after setting its record speed, in what I'm sure will be a surprise to anyone who's even remotely clued up on British transport infrastructure, the government pulled the funding. This was a massive project. The hovertrain did work. It was just quite a long and expensive way of being an operational train line, requiring years more development and construction of a whole new route.
Yeah.
Having invested the equivalent of
Totally new tracks, like a whole new system, very power hungry, and you can't ride on it. I mean, what would happen if people rode on it and the power went out? Yeah, but, if they didn't try it, we would all wonder, what if, what if?
£130 million into the project, the government cut its losses and decided it would be better to invest in the advanced passenger train, a conventional train that could tilt from side to side in order to speed round the corners of our existing Victorian tracks.
Oh.
Now that would do 125 miles an hour on conventional railway infrastructure, whereas this would have needed dedicated concrete beams, so the government put their money that way, and that's where this
Smart.
effectively stopped.
Logical.
Without a major backer, over 100 people on the hovertrain project lost their jobs, and RTV-31 was unceremoniously abandoned at an airfield in Cranfield. Standing next to it now is massive. Even today, it feels like something out of science fiction, so why have so few of us heard of it? The hovertrain didn't have an easy afterlife. Staff who used to work on the project joined up with volunteers at Railworld in Peterborough to rescue RTV-31 in 1996. But as a relatively low-profile relic, funding was hard to come by. Sat outside for 50 years, the structure has deteriorated, and there's word of it being dismantled altogether.
Well, what are you going to do?
These three
junk.
concrete beams are all that's left of the test track, slowly being reclaimed by the Cambridgeshire countryside. It's a reminder of just how easy it is for us to forget the things that came before us.
Wow, it's only been 50 years.
RTV-31 is too new to be considered particularly historic, but too old to be left out in the open. It was a test vehicle, it wasn't meant to stick around, and left outside, there's word that it might not survive much longer. The people at Railworld told me that the beam it sits on might be structurally unstable and they might not be able to remove the hovertrain intact. Some are saying it might not survive the year.
Whoa.
Many of the people who worked on the project are no longer around to tell the story, so it's up to a new generation to make sure the hovertrain isn't forgotten.
We're looking at 3 lumps of concrete in the middle of nowhere that many people don't seem to know what they are. Well, from what I can gather, when the project was cancelled, many of the staff became incredibly despondent, literally throwing things away. Paperwork, test material, you name it, it ended up in the skip. Somebody luckily had the presence of mind to kind of retrieve various things, and it is forming an archive. The film material is more than 50 years old. They're having to be combined, spliced together, cleaned, and then scanned in 4K, and then the restoration can begin. Oh. So I really want to put together a documentary that tells the definitive story of the hovertrain in a way that's never been done before.
That would be really interesting. There aren't often documentaries about these projects that go nowhere. It would be a good tragedy.
So often reported that the project was a flop. It wasn't. These guys did succeed. The moment they start talking about this thing, you can hear the passion in their voice. You can see their eyes light up. It's incredible.
What was learned here helped further develop maglevs, trains that hover using magnetic levitation, and LIMs instead of air. The LIM system was used to develop the old Airlink shuttle at Birmingham Airport in 1984, the air train at JFK Airport in New York, which is still there today, and most recently the maglev trains being built in Japan, which got up to 375 miles per hour.
Wow.
It wasn't the last ambitious idea for the future of train travel. Projects like Hyperloop, which not only floats but does so through airtight tubes, are still being developed today. But the same issues still exist. They're complex, expensive, and energy intensive. When we have a system that works, albeit slower, is it worth the investment? Well, with maglev taking off in countries like China and Japan, the answer for some is yes. And in all of these projects, the hovertrain's legacy quietly lives on. The future, not quite in reach, but tantalizingly close. This train never carried a single passenger. It never reached its full potential, but for a brief moment, it was the most ambitious transport project in Britain. And for now, you can come and see it. A train that hovers. Or at least, used to. Drew is doing fantastic work restoring the archives for a hovertrain documentary. If you're interested or want to support, there's a link below.
Oh, yeah.
Thank you to Manu for the amazing drone footage. I've linked his Instagram below if you want to connect. I've also linked a really informative piece which gives one of the best accounts available at the moment of the hovertrain. And thank you to Rail World in Peterborough. Everyone here has been so welcoming. It's a really impressive place. You should definitely come and check it out.
When I had to look after the local press was one big challenge. Keeping them away from the live rails and so on, keeping them safe whilst they wielded their camera tripods around.
Wow. RTV 31. When I first saw the thumbnail for this video, I thought it was going to be about lab buildings in Antarctica, because it looks like one of those movable labs. Dragged hovercraft. It combined two British inventions, the hovercraft and the linear induction motor. What is a linear induction motor? Oh, that's the LEM. Yeah, an AC current, asynchronous linear motor that works by the same general principles as other induction motors, but is typically designed to directly produce motion in a straight line. Let's ask the robots, please explain a linear induction motor in layman's terms. The electricity creates a magnetic field, and the magnets grab a rotor, and the rotor spins round and round. Oh, a linear motor, instead of rolling around in a circle, imagine cutting that motor open, unwrapping it, and laying it flat. Now, instead of making something spin, it makes something slide in a straight line. Okay, so it's like pulling it along with magnets. So although this hovercraft was a failure, it actually did lead to maglev trains in other places that were not hovercrafts. Y'all be sure to go to Luke O'Sullivan and like and subscribe. Rails in Peterborough? Shit, on a map. Rail World? There it is. Rail World Wildlife Haven. Let's see if we can find it. There it is. Wow. It's just sitting there. Right by a track. Right by the river. Very cool. Well, y'all be sure to go to Luke O'Sullivan and like and subscribe. I'd like to thank my patrons. I'd like to thank my Buy Me a Coffee folks. Thank y'all for watching this with me, and I'll see you next time. Later.